All right, this is a review for the second semester, final exam. And we start off with solving quadratic equations, which has been a big part of this semester. So the first one, you may use 3x squared minus 2x minus 8 equals 0. You may use whatever method you prefer. You can factor, you can complete the square, you can use the quadratic formula, whichever you prefer. I believe this thing factors. I may be wrong, but I'm seeing something that makes me think it's possible. This would be 3x and x. And if I multiply this by 2, I get 6, and 4 would make 2. I just need the 6 to be negative. And so I have 3x plus 4 times the quantity x minus 2. And then we just set each factor equal to 0. 3x plus 4 equals 0. X minus 2 equals 0. So here we would subtract 4 from both sides. And then divide by 3. Here we would just add 2 to both sides. So there's our two roots. X squared plus 5x equals 4. X squared plus 5x minus 4. Even though it looks like it, I don't think it's going to factor because the 4 is negative. Positive, I could use 4 and 1 to make 5, but the fact that it's negative, I can't. One of them will have to be. So I don't think this factors, so I'm going to go right into the quadratic formula, where I take the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And in the parentheses here, I'm going to get 25 plus 16, which is 41. So x equals negative 5 plus or minus the square root of 41 all over 2. And that's all I can do with that. Number 3, we have 3x squared minus 2x minus 5. And I think I might be able to get that to factor. Let's see. 3x squared, negative 2x, negative 5, 3x and x. 1 and 5, 3x and 5x. I need the 5 negative, and that works. So I have 3x minus 5 times x plus 1. So 3x minus 5 equals 0. X plus 1 equals 0. Move the 5. Divide by 3. Or remove the -1. So there's your answers. Number 4 is 3x minus 2 quantity squared equals 49. And there it is. And that's already set up for completing the square. Obviously, you take the square root of both sides. You get 3x minus 2 equals plus or minus 7. So to solve that, we say 3x minus 2 equals 7. 3x minus 2 equals negative 7. 3x is 9. X is 3. 3x is negative 5. X is negative 5/3. And number 5, 2x squared plus x equals 3. We have to move the 3 over. I think I might be able to get that to factor. 2x squared, negative 3, 2x and x, 1 and 3, 2x and 3x, and so see, I need this one negative in order for that to work. So I get 2x plus 3 times the quantity x minus 1. Remember to take those answers diagonally. 2x plus 3, x minus 1. So 2x plus 3 equals 0. 2x equals negative 3. X is negative 3 halves. X minus 1 equals 0. X equals 1. And I might have room for number 6 down there. Yeah, I do. Number 6. 36x squared equals 225. Divide both sides by 36. And those are perfect squares over there. They do reduce. But I'm going to leave it like that. And I'm going to take the square root of both sides. I'm going to get that x is plus or minus 15 over 6, which actually reduces to plus or minus 5 over 2. My answer like that. And then the last one on here, for the first part of the final, x squared plus 6x equals 12. So x squared plus 6x minus 12. And we are not going to get that to factor. Come over here to quadratic formula. The opposite of b plus or minus b squared minus 4 times a times c all over 2a. And in those radical there, I'm going to have 36 plus 48, which is 84. And then 84 simplifies, and I'm just going to simplify this. It's negative 6 plus or minus 2 square root 21 all over 2. And then I can divide everything there by 2. So I get negative 3 plus or minus the square root of 21. My final answer when I simplify everything. All right, number 8. We have y equals x squared minus x minus 6. And we're supposed to find all that good stuff, graph it, do all that. So vertex x equals the opposite of b over 2a. So vertex, the x coordinate is negative 1/2. I don't know why I wrote it again. And then to find the y coordinate, I plug that in, and I get y equals negative 1/2 squared minus 1/2 minus 6. And so I'm going to put in let's see, I'm going to cheat, use my graphing calculator here, minus x minus 6, and so then I get negative 5.25, which is negative 5 1/4. And then this opens up the y-intercept. So let's see, vertex is -1/2, -5 1/4. The axis of symmetry, x equals -1/2. The x-intercepts, I can find those now by setting this thing equal to 0, x squared minus x minus 6, and that thing factors to x minus 3, x plus 2. So my x-intercepts are 3, 0, and -2, 0. The y-intercept is 0, -6. And the domain is all real numbers. In the range, y is greater than or equal to -5 1/4. And then we would need to graph it. So you're estimating where that vertex is, but you can graph it more from the y-intercept. Your y-intercept was at 0, -6 right here, and then your x-intercepts were at, and then this would have a mirror point right here. Your vertex is going to fall in here somewhere, and then we had intercepts here and here, and so kind of get an accurate picture of what that thing looks like. And like I said, this part down here is just an estimate. So there's all the things for that. Number 9, same thing. Y equals -2x squared, so I know it's going to open down, plus 4x plus 1. X equals -4 over -4, which is 1, meaning y is -2 plus 4 plus 1 is 3. So your vertex is at 1, 3. Axis of symmetry, x equals 1. Okay, your x-intercepts on this one are not going to come out nice, so we'll find that in a minute. Your y-intercept though is 0, 1, and your let's see, y-intercept domain, all real numbers, and your range would be y is less than or equal to 3. To find the x-intercepts, we would need to set this equal to 0. And I don't believe it factors. So right to the quadratic formula, b squared plus or minus, I'm sorry. This is my 3rd video today, so I apologize. Opposite of b, which is -4 plus or minus b squared minus 4 times a times c all over 2a. And we get 16 plus 8 is 24. And the square root of 24 simplifies to 2 square root 6. And then what I can do to simplify that is divide everything basically by -2. So it's going to give me 2 plus or minus the square root of 6 all over 2. And those are your x-intercepts. So for the x-intercepts, you can write 2 plus the square root of 6 over 2, comma 0, and 2 minus the square root of 6 over 2, comma 0. And then graph it like we've graphed all of these. Your vertex is at 1, 3, and then I would plug in 0 and get your y-intercept here, and then use the axis of symmetry. And then I would plug in either 3 or -1 and get the next point, and draw in. But you do need to get that next point and then draw in your parabola. Number 10 has right triangle. This is 2x. This is x plus 1. This is x plus 3. And so we would use the Pythagorean theorem to find x, since this is the right triangle. So 2x squared plus the quantity x plus 1 squared equals the quantity x plus 3 squared. So leg squared plus leg squared equals hypotenuse squared. You just have to remember that when you multiply this out, this is x plus 1 times x plus 1, and this is x plus 3 times x plus 3. And so when you multiply that, you get x squared plus 2x plus 1. You get x squared plus 6x plus 9. Notice over here that I have 5x squared plus 2x plus 1. And I'm going to move everything over to the left. So I'm going to subtract x squared. I'm going to subtract 6x. And I'm going to subtract 9. And so I get over here 4x squared minus 4x minus 8 equals 0. And I'm solving this for x. And there is a greatest common factor. And I believe that does factor. And then we can set each factor equal to 0. Obviously the 4, divide both sides by 4, the 4 drops out. X minus 2 equals 0. X plus 1 equals 0. X equals 2. X equals -1. The -1 doesn't work because that would give me this side length is -2, and this side length would be 0. So we throw that out. X is 2 is our answer. Number 11, square root of 240 in simple radical form. So we break that down. That's 2 times 120, and that's 2 times 60, and that's 2 times 30, and that's 2 times 15, and that's 3 times 5. So here are two alike. One comes out, one disappears. Here are two more alike. One comes out, one disappears. So I have the square root of 15 left. So this is 4 square root 15. And then answer on a quiz. Number 12 has the square root of 36 x to the 7th times 7 times the square root of 25 x to the 3rd. Well, this is a little precarious. We have 7 out there already, okay? And then they gave me two perfect squares. The square root of 36 is 6, and the square root of 25 is 5. Okay, I don't even need to factor those out, and I recognize them as perfect squares. I'm just going to take the square root. And so that's what I do. And then I have x to the 7th times x to the 3rd, which is x to the 10th. So when I multiply this out, I get 210, and the square root of x to the 10th is x to the 5th. So when everything comes out of that radical, then the radical sign disappears, and that's just our answer. Okay, number 13. What's the discriminant of 3x squared minus x minus 5 equals 0? Remember, the discriminant is b squared minus 4ac. So it's going to be 1 minus 4 times 3 times negative 5, which is 1 plus 60, 61. And then number 14 says use the discriminant to determine the nature of the roots, and without solving. So again, 9 minus 4 times 2 times negative 7. That's going to be 9 plus 56, which is 65. All right there. And so that is a positive number. And when the discriminant b squared minus 4ac is greater than 0, that means that we have 2 real roots. And that would be the nature of the roots. We're going to get 2 real roots. In this case, because that's not a perfect square, these roots would be irrational. But we're not asking you to determine that. Okay. Number 15. We have y equals 3x and y equals x squared plus 3x minus 4. And so this is set up for substitution. It's y equals and y equals. So I'm just going to set them equal to each other. X squared plus 3x minus 4 equals 3x. Notice that the 3x's drop out. So I get x squared minus 4. I can solve this using square roots. X squared equals 4. X is plus or minus 2. That was nice. So these two, this line and this parabola, intersect at the points 2. Then I plug that in here and get 6. And at the point negative 2, and I plug that in here and get negative 6. And easier than it looked. All right. Solve each of the following equations. 16 is negative 5x plus 7x equals 2. So I'll get this down in your view here. Combine like terms, I get 2x equals 2 and x equals 1. 3x plus 4 equals 3x plus 2. And when you go to get your x's together, they drop out. You get 4 equals 2. That is not true. It's false. So this has no solution. 18. Negative 2 times the quantity 3x minus 1 equals 24. So distribute the negative 2. Negative 6x plus 2 equals 24. Subtract 2 from both sides. Negative 6x is 22. Divide by negative 6. X is negative 11 thirds. Number 19. the absolute value of x minus 5 equals 7. So we apply the definition of absolute value. X minus 5 equals 7. X minus 5 equals negative 7. We add 5, we get 12. We add 5, we get negative 2. So those are our two answers. Number 20, y equals 2x minus 7. 9x plus y equals 15. So this is already set up for substitution. We want to find where these two lines intersect. I'm just going to take that and substitute it in there for y. So I get 9x plus 2x minus 7 equals 15. 9x plus 2x is 11x. Add 7 to both sides, and I get equals 22. Divide by 11, x is 2. And I'm going to take that, I'm going to plug it right here for x. So y equals 2 times 2 because x equals 2. And 4 minus 7 is negative 3. So where do these two lines intersect? They intersect at the point 2, negative 3. 21. 5x plus 6y equals negative 6. And 7x minus 3y equals negative 54. So it looks to me like if I were to multiply this second equation by 2, the y's would drop out, and I would be able to solve that for x, and then substitute that in somewhere to find y. So let's do that. 14x minus 6y equals negative 108. That's going to be 19x equals negative 114. And that comes out to be negative 6. So x is negative 6. I'm just going to plug that in here and get negative 42 minus 3y equals negative 54. So I would add 42 to both sides and get that negative 3y is negative 12. Divide by negative 3, and I get that y is 4. So these two lines intersect at the point negative 6, 4. We're supposed to graph y equals negative 3/4 x plus 5. And if I do that, I start with the y-intercept is at 5. Slope is negative 3/4, so down 3, 1, 2, 3 over 4. It's negative, and that line has a negative slope, so probably looks something like that. Number 23, we're not in slope-intercept form, so negative 3y equals negative 2x plus 6. Y equals 2/3 x minus 2. So again, negative 2 is our intercept, and then our slope is positive 2/3, and there's your line. Well, you can't see that. No, you can't. Y-intercept, rise 2, run 3, positive slope. 24. F of x equals the absolute value of x plus 3. So the parent function is f of x equals the absolute value of x, and that is that. This is going to take that parent function and move it to the left 3. If you're not confident with that, plug in numbers. If I plug in 0, I get 3. If I plug in -1, I get 2. If I plug in -2, I get 1. If I plug in -3, I get 0. If I plug in -4, I get 1, and so on. So I missed, but basically, like I said, it's going to move it to the left 3. 25, y equals 3 to the x. Remember, that's exponential. So the parent function, it basically could be 3 to the x. If I plug in 0, anything to the 0 power is 1. If I plug in 1, I get 3 to the first. If I plug in 2, I get 9, way up here somewhere. If I plug in -1, I get 1/3. If I plug in -2, I get 1/9. And if I plug in -3, I get 1/27. So if you recall, this is getting closer and closer and closer to the x-axis over here, but it's climbing exponentially going this way. Okay? So that's what any exponential function looks like. 26. Write an equation a of x to find the area of the shaded region. I'm just going to come over here to this paper now. So find the area of the shaded region, which means I want to take the area of the whole thing, and the area of the whole thing is 5x minus 3 times x minus 2, and I want to subtract the area of the inside, which is x times the quantity x plus 5. And we just multiply that out. So 5x squared minus 10x minus 3x is minus 13x plus 6 minus x squared minus, because you have to distribute that negative as well, 5x. And then we just combine like terms. It looks like I'm going to get 4x squared minus 18x plus 6. And that's the answer we're looking for. You would not factor out the greatest common factor there, because that's not what I asked you to do. I asked you to write an equation, a of x, that would be the area of the shaded region, and that's it. Didn't say solve or factor or anything like that. Just said a rectangular park is 5x plus 3 feet long and 4x plus 7 feet wide. In the middle of a park is a square turtle pond that is 6 feet wide. So it's a square, so all the sides are 6. What expression represents the area of the park not occupied by the turtle pond? So the area of the park not occupied by the turtle pond would be the area of the whole thing minus the area of the turtle pond. So, and again, it's just asking for the expression. So a of x equals 5x plus 3 times 4x plus 7 minus 36. So the 20x squared plus 35 plus 12 would be plus 47x plus 21 minus 36. And then this would be minus 15. So I took 5x plus 3, 4x plus 7, subtracted the turtle pond, which is 36, and multiplied it out, and then combined like terms. And that's my answer. It's not asking me to solve anything. And this last question, it is asking me to solve. It's asking me to find the area of the shaded region if the total area is 198 square centimeters, sorry. So this whole length here is going to be 16 plus x. and this whole here is going to be 1 plus x. And I would prefer they be written the other way around. So basically I'm going to take x plus 16 times x plus 9, subtract 16 times 9, and that needs to equal 98. So I get, when I multiply this out, I get x squared plus 9x plus 16x would be 25x plus 16 times 9 is 144 minus 16 times 9 equals 98. And I get x squared plus 25x minus 98 equals 0. And that's not going to factor. So I need to use the quadratic formula to solve this. So x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2a. And those in that radical there, I'm going to get I'm going to get negative 25 plus or minus the square root of 1017 divided by 2. Believe it or not, that simplifies to negative 25 plus or minus 3 times the square root of 13 all over 2. And I must have, I don't know, somehow written the numbers down incorrectly or something, because that is not working out, or I've made a mistake somewhere. 16 plus 9 is 25. That's right. Shoot. My mistake, I found it. When I simplify this over here, this should be the square root of 113, not 13. Sorry. And then obviously negative 25 minus that is not going to work as a possibility, but negative 25 plus that will. And so I take negative 25 plus 3 times the square root of 113, and then I take that divided by 2, and I get that x is approximately 3.45. And so that's what they would be looking for, is that. If I made this problem up, chances are it's probably going to work out better on the test. Sometimes when I make these up, I try to change the numbers to numbers that I think are going to work, and they don't work, or this isn't what I intended it to be. I'm not, so anyway, that's that.